a farmer has 100 feet of fencing. He would like to use the fencing to enclose 3 sides of a rectangular-shaped pig pen to be built against a wall of the barn. That is, the barn is being used as one side of the enclosure. Find the length of the side of the pig pen parallel to the barn, X, that gives the largest area of the pen. So we should start out with a sketch here. Here is the barn, so let's label that. That's going to serve as one side of the pig pen. And then what we have is we have one side coming out here, another side going across, and finally this side here. The total amount of fencing that is used here is 100 feet, which is given in the problem. And we know that the amount of fence associated with the side parallel to the barn is X. So let's label that this way. If we devote X to this side, then if we have a total of 100 feet, then we must have 100 minus X feet left to devote to these two sides. And you devote the same amount to each side, so that is to say, you take 100 minus X and divide by 2, and that will be this length right here, as well as this length right there. So now we can write the area as a function of X, and that'll be written as A of X. We're used to F of X, but because this is an area, that could be A of X. And the area in this case is simply going to be this length times this length, and that will account for the area. So you have X multiplied by 100 minus X divided by 2. The 1/2 can be pulled out front, and when you do so, you get 1/2 multiplied by 100x minus x squared. And one way of solving this problem is to plot this function right here. And when you plot it, you will see you will get a concave down parabola, and you just pick off the highest point. So that's the graphical way of solving this. There is an analytic way, and that's what I'm going to look at now. First thing I'm going to do is I'm going to multiply both this quantity and this quantity by -1, and that's going to give me -1/2 multiplied by x squared minus 100x. Now, it may not be the obvious next step here, but one thing you can do is you can complete the square and take x squared minus 100x and add the appropriate value right here that makes this quantity into a perfect square. And of course, we have to adjust for that over here. So the way you complete the square is you take this coefficient in front of the linear term, and that's -100, and you take half of it. Half of -100 is 50, -50 that is, and then you take -50 and square it, and -50 squared is 2500. That gets added right here. Now notice, because of the -1/2 right here, we didn't really add 2500. What we've done is we have subtracted half of that, which is 1250. So since we have subtracted 1250, we have to go back and add in 1250. So now we have this as a perfect square. And so this is -1/2 multiplied by x minus 50 squared plus 1250. So now is a good time to kind of think a little bit about this equation. What this says is that the area is equal to 1250 minus some amount here. Well, if we want this amount that is being subtracted off to be as small as possible, the smallest this amount can get occurs when x is equal to 50. So I'll write that out here with more detail. A of x is maximized when x is equal to 50. Now, when you take a calculus class, there is a much easier way of doing this, but that is the solution right there. You should devote 50 feet to this side parallel to the barn, and if you have a total of 100 feet, that leaves 25 here and 25 here, and that is the pig pen that will give you the largest area possible.